Show that one and only one out of n, n+2 or n+4 is divisible by 3 where n is any positive integer. Let us assume n as a positive integer and b equal to 3. So using Euclid's division algorithm, we would get the equation with these two integers as n equal to 3q plus r, where 0 less than or equal to r less than 3. Now if we consider for r equal to 0, n is equal to 3q. So for n equal to 3q, this is divisible by 3. Now next, n+2. So if we add 2 on both the sides, the equation would become n+2 equal to 3q plus 2. Similarly, for n+4, our equation would become n+4 equal to 3q plus 4. Here we can see that only n equal to 3q is only divisible by 3. R equal to 1, n equal to 3q plus 1. n+2 will be 3q plus 1 plus 2. So that would be 3q plus 3. Similarly, n+4 would be 3q plus 1 plus 4. So that would be 3q plus 5. Here, out of all the three equations, only n+2, which is equal to 3q plus 3. So we can take 3 as common. So we can see that this equation is divisible by 3. Here, n+2 is only divisible by 3. For r equal to 2, n equal to 3q plus 2. n+2 will be 3q plus 2 plus 2, 3q plus 4, and n+4 will be 3q plus 2 plus 4, that would be 3q plus 6. So out of all the three equations, we can here take out 3 as common. So out of all the three equations, n+4 is only divisible by 3. Therefore, you can see in three of the conditions, either n or n+2 or n+4 is only divisible by 3, but not all the three terms at the same time. So we can clearly say that one and only one out of n, n+2 and n+4 is divisible by 3. Take a screenshot or download the solution from the link in the description box.